Charle's Law. It is an experimental gas law that explains how gas appears to expand when heated. The physicist used to work at the Bureau of Finances, and his name was Jacques Alexander Charles, who was born on November 12, 1746, and died in Beaugency, France in 1823. Then after a visit by Benjamin Franklin, he suddenly became a mathematician and a physicist because of inspiration. Hot air balloon was so popular at that time, and when he witnessed it float up higher, that is where he started studying gases and how it works. Then suddenly, winter came during 1877, where he started to experiment on balloons filled with nitrogen, oxygen, and hydrogen, then found out that it got smaller and smaller when it is exposed to cold temperature. We also have a formula that is used to compare volume and temperature. V1 is divided by T1 equals V2 divided by T2. So this is the formula that we will be using for a problem later. Let us apply the formula. A gas with a volume of 5.67 liters at a standard temperature is placed above the fire to the temperature of 185 degrees Celsius. What is the new volume of the gas? First, let us identify the given variables. The volume number 1 is 5.67 liters. Temperature number 1, 0 degrees Celsius, and temperature number 2, 185 degrees Celsius. Notice that volume number 2 is missing, so that is the variable that we will be identifying using the formula. Now, before solving for the final volume, we must convert the following Celsius to Kelvin. Note, 0 degrees Celsius is equals to 273.15. So all we have to do is add 273.15 to the following Celsius. 0 plus 273.15 is equals to 273.15 Kelvin. Second, 185 degrees Celsius plus 273.15 is equals to 458.15 Kelvin. The final temperatures are temperature 1, 273.15 Kelvin, and temperature number 2 is 458 Kelvin. Since B2 is missing, we cannot use the formula that I have given. We have to derive a new formula so we can easily solve for final volume by dividing both sides by T2 and cancelling the same variable on the right side, leaving us with V2 and a new formula. Let us solve for the final volume. Substitute the given variables onto the formula. 458 Kelvin times 5.67 liters divided by 273.15 Kelvin, which is total to 9.5 liters. To use Charle's law in solving for the final volume.